What makes Na-ion, sodium-ion batteries a promising alternative, and how does his research explore their advantages and limitations? What are Li-S lithium, sulfur batteries, and how do they differ in structure, energy density, or chemical behavior compared to more traditional lithium-ion batteries? What challenges do Li-air batteries present, and what potential breakthroughs has he sought in this area of research? How does his work contribute to the global push for cleaner, more efficient, and more scalable energy storage solutions? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What methods does he use to synthesize and test new electrode materials, and what scientific principles underpin those approaches? What impact has his research had on the battery industry, both in academic and industrial contexts? Has he collaborated with other institutions, companies, or researchers to further his investigations, and what has resulted from such partnerships? How might his long-term work on alternative battery chemistries influence future energy storage technologies, including those used in renewable energy systems, mobile electronics, or electric mobility? How does his experience bridge both industrial innovation at Samsung and academic inquiry at Hanyang University? And how does that combination of perspectives enhance his contributions to the field? How does his role as a professor influence younger researchers, and what kinds of mentorship, training, or academic programs does he provide to support the next generation of energy scientists? What are some of the publications or patents associated with his name, and how have they shaped contemporary battery research? What has been the evolution of his scientific focus from early lithium-based technologies to more cutting-edge chemistries like lithium, sulfur, and lithium-air? In what ways has his work addressed critical problems in energy density, charging time, battery lifespan, cost, and environmental impact? How does his research help address the global energy challenge and the transition away from fossil fuels, especially in the context of sustainable electrification and grid storage? How might governments, industries, or research institutions benefit from the technologies and materials he has helped develop? What role does South Korea play in the global battery market, and how has Youngkook Sun's work contributed to that leadership? How might his continuing efforts at Hanyang University drive future innovation in battery materials science and energy storage solutions? What are fossil fuels, and why have they historically been the most widely used energy resource around the world? What kinds of risks are associated with the continued use of fossil fuels, and how do these risks relate to resource depletion, environmental pollution, and political unrest?